Hi Geometry, this is page 6 of our packet, and we're going to start using our 5 triangle congruence theorems to prove two triangles are congruent to each other. We can't say it just because they look like it. It has to fit one of our 5 theorems that are listed on page 5 right before this, and also on page 4 in our foldable with the little doors. We're looking for side, side, side congruence theorem. That's when all 3 sides of one triangle are congruent to its corresponding side in the other triangle. We're looking for side, angle, side. That would be the included angle in between 2 congruent sides. We're looking for angle, side, angle. That would be the included side in between 2 congruent angles in the 2 congruent corresponding angles in the 2 triangles. We're looking for it to be angle, angle, side, which you could list side, angle, angle. Or if it's a right triangle, sometimes it's HL, hypotenuse leg. Again, those definitions are on page 4 inside our foldable with the little doors on it, and also on page 5. If you need more help with those definitions, there is a video for page 4 for the foldable that you can watch. So I'm going to jump around this page because not everything on this page is congruent. Not all of these examples fit one of these 5, and I'll come back to those at the end. So I'm going to start with 3. So sometimes we need to add markings to our diagram. So in this diagram, angle A in the top triangle is congruent to angle D in the bottom triangle, and side AE is congruent to side DE. And that's all we know. And I'm trying to decide if the 2 triangles are congruent. Well, it doesn't fit any of the 5 theorems right now. So this is where I'm going to add information that I know because I've learned about it in my geometry class. Namely, there's 3 things. Sometimes we add markings for vertical angles because vertical angles are congruent. Sometimes we add markings for the reflexive property. That's when we have shared sides. And sometimes we add markings for parallel lines. Usually 99.9% of the time, that will be alternate angles. And we know that alternate interior angles are also congruent. So in number 3, I do have one of those things. I have vertical angles in number 3. If you look at AEB, this is a vertical angle with DEC. They are across from each other where 2 lines intersect, and so vertical angles are congruent. So now when I look at number 3, I can literally see let me grab my red color for just a minute. I can see an angle, side, angle in one triangle, congruent to an angle, side, angle in another triangle. So yes, these 2 triangles are congruent. They are congruent by angle, side, angle. The S is in between the 2 A's. The side is in between the 2 angles. It's the included side, very important. So now I know the 2 triangles are congruent to each other. I can prove it with my angle, side, angle theorem. I don't always need to know all 6 things. I don't always need to know that it's a reflection, translation, or rotation. Sometimes I can know 2 triangles are congruent because it fits one of these 5 theorems. And the theorem that number 3 fits is angle, side, angle. So let's take a look at another vertical angle problem. I'm actually going to jump down to number 7. So in number 7, as it's given to me, I have 2 sides congruent, AK and SK. I also have DK and TK congruent. And right now that's all I know, 2 sets of sides. However, there are things that I mark because I know them. Those 3 things are vertical angles, reflexive property for shared sides, and alternate interior angles. So in this diagram, I have vertical angle at K, so AKD is congruent to SKT. So now I look at my drawing. Let me grab a third color, And as I'm looking at it, I see I have a side, an included angle, and a side of one triangle congruent to the side, the included angle, and side of another triangle. So yes, these two are congruent by my side, angle, side congruence theorem. So now I know all 6 parts, all 3 angles, all 3 sides, all corresponding parts of these two congruent triangles are congruent. So now let's take a look at the reflexive sides. Let's jump up to number 4. So on number 4, you'll notice that we have XW and ZY congruent, and we have XY, and we have WZ congruent to each other. That's all I know. And I don't happen to have vertical angles here. I also don't have alternate interior angles. There's no parallel line marks. However, I have my reflexive property right here. WY is in both triangles. So this is my reflexive property. This is a shared side. Both of these triangles share this side. So I'm going to mark it. I'm going to mark it with 3 marks so it looks different because it's in both of the triangles. It's in the triangle on top and it's on the triangle on the bottom. And so it's congruent to itself. And now I can clearly see I have no angles marked, but I have all 3 sides in one triangle congruent to the 3 sides in the other triangle. This then is an example of my side congruence theorem. Let's take a look at another problem that has the reflexive property. Let's take a look at number 6. In number 6, this particular diagram has a shared side that's not marked. WY is in both triangles. I'm going to go ahead and mark it. This is my reflexive property. That's why I can mark it. WY is congruent to itself. And now, because this has a right angle mark, some kids automatically think, oh, that's going to be an HL, right triangles, hypotenuse leg. But it's not. My hypotenuse is the longest side. That's always across from the right angle. WZ, for example, is my hypotenuse. And you'll notice there's no markings on it. I don't know anything about my hypotenuse. But I do know that angle Z is congruent to angle X. I know that angle Y is actually on both sides a right angle because the straight line adds up to 180, so 90 and 90. So what I have in this picture, let me grab a different color. I have an angle, another angle, and a non-included side. Again, I have an angle, another angle, and a non-included side congruent to the other triangles. Angle, angle, non-included side. This is an example of AAS. Some students write SAA. That's fine. Notice the S is not in between the 2 A's. Up here, my S was in the middle because my side was in the middle of the 2 angles. On this one, my side is not in the middle of the 2 angles because in the diagram, my side, the one that's congruent, is not in between the 2 green angles. Let's take a look at another one with the reflexive property. Let's take a look at 9. On 9, it has the reflexive property as well. It's not marked. It's this shared side. You're always going to mark those. That's my reflexive property. So I'm always going to mark it. I'm going to mark it with 2 because I already have RU congruent to RS. Now, this is where I want you to notice that this is a right triangle. My hypotenuse is always the longest side. It's always across from the right triangle. So I have the hypotenuse, RU, congruent to the hypotenuse, RS. And then this would be a leg. My reflexive property, my RT would be a leg. This is an example of hypotenuse leg. This is a right triangle. And I have the hypotenuse and leg of one congruent to the hypotenuse and leg of the other. It's a perfect time to use my hypotenuse leg. Now, you'll notice I did skip a few of these. Let's go back and look at 2. 2 is going to be an example of not congruent. I know they look congruent. They do look the same size. But the problem is it won't fit one of my 5 known theorems. So in this diagram, I have angle M congruent to this other side, angle M, and I have ON congruent to OP. At this point, I don't have any vertical angles, but I do have the reflexive property. I am going to mark my shared side. That's this OM. This is my reflexive property. I'm going to mark it. However, when I do that, some students will look at this and they'll say, okay, well, I have an angle, I have a side and another side, not the included angle O, but angle M, the non-included. So they'll just write side, side, angle. So they'll write the A so it's not in between the two sides. But if you look back at page 4 and you open the flap, the bottom right flap, you'll see that side, side, angle, which when you spell it backwards is the bad word, angle, side, side. You'll see that it is one of the methods that do not work. So for number 2, you would have to say that this guy is not congruent, or some students say not enough information. I mean, I know some stuff about this diagram. I just don't know enough to say that it's congruent by side, 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 angle, 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 side, and it's not a right triangle, so certainly not HL. So in this particular example, number 2 doesn't work for that reason. As you look at 1 and 5, they similarly also don't work because I don't have enough information. On number 1, I just have the reflexive property, so I have like a side set up, but I don't have anything else. I don't know AC and DC, that third side. I don't know any of the angles. So again, not congruent, or you could write not enough information. It doesn't fit any of my 5 theorems. So the rest of this page, why don't you try going through, marking your vertical angles if they're there, marking your reflexive property if it's there. There's one problem with alternate interior angles. I'll look at that before the video is over. But why don't you try filling these in or identifying if you can't, if it doesn't work, if it's not one of the 5, and you'll be able to check your answers in the folder. Before we leave this page, let's go down and look at my one problem that has alternate interior angles in it. So if you go looking down on this page, I only have one example that has parallel line arrows. Those are not congruent marks. Those are parallel line arrows. And when you see those, this is my parallel line. And you could think of US or UT, it doesn't really matter, but you could think of US as being a transversal. So this creates a Z. The 2 parallel lines and the transversal create a Z shape. In the corners of my Z are my alternate interior angles. Those angles, alternate interior angles, are something I have to mark on my own. So when you see parallel line problems, we need to look for my Z so that I can put in my alternate interior angles. There's another angle in this diagram I have to mark. Did you notice the vertical angles? At O, I have to mark those as well. So now when I look at this, I have an angle, the included side, and another angle congruent to the angle, the included side, and the other angle of another triangle. This is an example of angle, side, angle, congruence theorem. Try the rest of these and check them in the folder. See you in class.